that we saw yesterday was that you know what the remainder is by plugging in, or you know by the remainder what would happen if you plugged it in. So what we saw yesterday, plugging in shows us the remainder. So that's what I mean by at the very beginning of your back of your homework spiral, the 2.3 opener. How do you show me this guy works before you keep on going and factoring? You can just plug in 2 if that's easy for you, but if that's not easy for you, you can just do synthetic and then look at the remainder. But what should happen when you plug in or when you do synthetic? What should you end up getting at the very end? 0. And after you get 0, you know, ha-ha, it works, and then keep going to factor it completely. Ready, set, go. Ready, set, go. Either plug in first or do synthetic division first, and then finish factoring. Shouldn't take you too long. I'm going to start playing with it in just a second, but I want you and your groups to be able to go as far as possible first. Just because I like mental math, just because I like it, I would have checked that 2 worked by plugging in first. So 2 cubed would have been 8 minus 7 and 2 is 14 plus 6. 8 and 6, 2 positive numbers. 14 minus 14 is 0. So I would have known before going to synthetic that the 2 was good. You didn't have to do it that way. You didn't have to. I just like mental math, so I would have plugged in the 2 and seen before I even went to synthetic, hey, my remainder is 0, so I know it works. That's how I like to check. Then I would have plugged into my synthetic. Joe, remember I just said that was my opinion? I'm not making a definitive statement. Huh?
I just realized there's 4 plugging after this.
Ah, good. So now synthetic, you could have just started here. And when you went, and when you multiplied, and when you added, and when you multiplied, and when you added, and when you multiplied, and when you added, didn't you also get that it goes in? So whether you go here, you know it works, or whether you go here, you know it works. But what's extra special or extra nice when you go here? What do you have left over? Yeah, the rest of what comprises the polynomial. Sorry, Tyler, go ahead. You're good. Okay, so if I now have this, could I go do synthetic some more? I could. I could try plugging in my list of possible zeros, and I would have 1 and 2 and 3, and wait a minute, this is way farther than we need to be going. This is section 2.5. But I could have kept going and trying other things, but the point was actually we didn't have to. I heard some of you guys talking about this. We're going to come back to what to do with the 2 in 1 second, but what can we do with this guy? But what kind of polynomial is he going to be if I started with a cubic and I took away a factor? What's left? It's a trinomial with what degree? Squared. So it's going to be 1x squared plus 2x minus 3. Now, what did you guys come to? What's your consensus as to what this is, x plus 2 or x minus 2? Why does it have to be x minus 2? We're not done yet, but this is the next step. Oh, yeah, I wanted the factors. So there's one factor. But why does this have to be the factor for 2? Because this is the 0. What's the 0 of x minus 2? Positive 2. What's the 0 of x plus 2? -2. So that wouldn't have worked. You had to do x minus. And that's why in our notes, I think we said the 0 is a, and the factor is x minus a. But anyway, we're not done yet, because what should we try to do? Yeah. And is it possible to factor -3 to make 2? Yes. Definitely, because you have 2, 3, and a -1. So pretty quickly you can get x minus plus 3. I don't know why I'm struggling writing today. I'm sorry. X plus 3, x minus 1, x minus 2. Was I supposed to, were you supposed to, according to the directions, go any farther? Any further? Nope. Because it said just factor. Done. Would have been the directions if it asked you to go even more. Find the zeros. Then you would go setting everybody equal to 0 and solving. But it just said factor. Completely. And I'm done. Questions? Lauren? No. No. Thanks for pointing that out. I was having too much fun. I caught that one and I didn't catch that one. All better. Any other questions? Matthew? Original. We're going to talk about it in section 2.5, but just because I know you're going to think about it now. You would technically look at the last term and think of all his possible factors. 1, 2, 3, and 6 go in. Look at the first term. It's just a 1. Think of all his possible factors. And then you pair them all up. 1 over 1, 2 over 1, 3 over 1, 6 over 1, plus or minus. Those are the only possible nice zeros. So you could try plugging in 1. Doesn't work. -1. Sorry. 1 would work. If you try plugging in 1, it would work. Do synthetic division. If you tried instead -1, you wouldn't get a 0, or you wouldn't get a remainder of 0, so you would have taken him out of the running and worked your way through the list. If the only zeros are nice, you'll find them all by going through those. But as soon as you find 1, I would break it down and have a simpler polynomial left. So technically down here, let's say this was a quartic, and let's say you had left a cubic when you divided. You would probably want to reevaluate a new list of zeros because some will get eliminated in the process. But we'll get back to it, don't worry. Okay, moving on. Let's go over homework because we need to go to section 2.4, imaginary numbers, complex numbers today. But first, let's grade. So, you guys should already be in your homework spirals. Just turn to the homework part. Color pens at the ready. The first problem was a long division problem. You didn't have an option because they told you to use it. I mean, you did have free will, so you could have disobeyed the direction, but you shouldn't have done anything different. And some of you might be like, I don't think I want to do synthetic with that anyway, because it's not of the form x minus or plus a. It's just, Joe and I talked about it for a while. Was that yesterday after school? I just don't want to. Because one way or another, the synthetic division would need a fraction, and that's not fun. So long division. Do you see them avoiding killing seals? I don't see them doing anything with seals, right? You got to be careful when you check your calc at work. Did they even write a minus to even distribute? No, so you have to be careful. Because it's 6 minus 6x cubed minus 6x cubed, and then -16 minus a -4. So if you made a mistake, be careful. They're not showing all of their work of subtracting and then distributing the subtraction. So it's going to look weird. This is not 9. Yeah, but if you think of it as division with the minus, it is 9. Beware your seals. Number 30, you guys can already see. Synthetic was perfect because it had a nice little division by a linear factor. Synthetic was a perfect way to go. But it didn't turn out very perfectly, did it? Did you guys get 199? Yeah. Did it scare you? You tried it over and over again? 199 was right. How could you have made sure 199 was right without having to do the synthetic again? You could have plugged it in. You would have gotten, I know, right? It would have been really bad. But you would have gotten 199 and been like, well, it's gross, but it's right. Cool little trick. Might be nice on a test someday. This guy, he went in super nicely. Remainder was 0. Why are they writing this? I don't think the directions asked for domain, did it? So why are they writing that? Did they write it in this one too? No. Why would they not? Because both of these are division. This one's dividing by x minus 9. This one's dividing by x plus 6. Why didn't they write it here? But they did write it there. We're going to talk more about this in section 2.6 when we talk about rational functions and denominators and discontinuities, wholes, and vertical asymptotes. But for right now, is this allowed to be 0? The denominator. Yes or no? No. Domain problem. So what is x not allowed to equal all the way back here? Well, negative 6, right? So x is not allowed to equal negative 6. Well, why didn't they say it then? Because when you divide, the denominator disappears, so you might obliviously say, oh, x can be negative 6. Wait, it didn't disappear, did it? Isn't there still a denominator that's still holding on to the meaning of x not being negative 6? But what happened in this guy? Is there any denominator to hold on to the meaning? No. So you could obliviously be like, oh, x can be anybody. No, no, no. From the very beginning, x could have never been 9. So it's just a reminder, if you do divide something away, hey, from the very beginning, x couldn't be 9, and when you divide away, you'll forget that unless you remind yourself. That's what's going on there. 60, you guys are just factoring completely, a lot like the opener that we just did. Negative 4 in the box, remainder is 0. That's a quadratic that you finish off with, most of you, the x method, right? Hey, they kept going. Why? Because they asked for the zeros. Was that it? Psh. That homework shouldn't have been too bad. Just kidding. Are there any questions? Evens or odds?
Can you do number 81?
Yeah. Anything else before 81?
Yeah.
14? Let me go to the long division on that one, Jordan, just to give you another second to look. I'm going to actually show my work on it because I'm pretty sure if something went wrong, it was probably a seal. Were these matching up kind of, at least at the beginning? Go to the textbook? Yeah. Do you think maybe did the wrong one?
Wait, yeah, oh, that's what, I wrote the 4x plus 5.
Ah, yeah. Make the correction real quick and then you'll know why. Yeah, it's nasty. Yeah. Priscilla.
I just have a question about the synthetic division.
Yeah.
How do you change the sign other one so it's negative?
No, always change the sign. So if you're using synthetic for like this whole section, in the box, 5. In the box, negative 3. In the box, 3. So think every time you're given a factor, always find it 0, which is always going to flip the sign. Good. We can peek at it. But now it's going to make a lot more sense when you see the 3x instead of the 4x, right? Because now it's like, oh, it goes in nicely, 2x squared times. And then you have to remember your distribution to get your 6x cubed and your negative 4x squared, like we did yesterday in our long division. You have to distribute that negative to not kill a seal. Division problems. Whenever you divide, we always put the subtraction. Does that make sense? They just aren't showing their, all of these have subtraction. Oops, sorry. All of them have subtraction, which is why this isn't becoming 18x minus 12. It's becoming 0. They're just not showing the minus because they don't want to show the distribution. They're being lazy, basically. Long story short. Okay, back to the book. I'm going to 81 unless someone stops me somewhere sooner. I'm trying to go to 81. Thanks, Jason. But we're good? Okay. Jason, how far did you get on it? What were the directions telling you?
Directions say to simplify or synthetic.
Technically or synthetic. Why did you naturally kind of just pause on long division?
Because those are 2x.
Yeah. I think it'd be smarter to do long division also. Just a few of you might try to do synthetic division. The problem, if you do synthetic, you're going to have to find it 0, which, Priscilla, using your idea, the 0 of this would be 3 halves. So we'd have to actually go all the way and not just steal the 3. So we would set that equal to 0, 3, 3 halves. But the problem is If you divide synthetically by 3/2, Joe, this comes back to your question the other day. What you're really doing is you're saying this guy is the exact same thing as that guy, but my question to you is it the same? You actually would need to do that to be able to do synthetic division, and all of a sudden your answer here needs to be divided by a 2. That just gets confusing. It's not impossible, it just gets confusing. You can take the 3/2, you can plug them in the box, but the problem is you'd have to pull out a 2 first to make that legal. And then when you divide by this guy, there's another 2 that has to come out to make it all legal. So some of you might want to play with that because you really like synthetic division. The dilemma is what comes out is not the natural perfect right answer yet. So long division, Jason, I'm assuming that's the way you went? Didn't need to put any zeros, right? Okay, what do you get for your first term? And I totally agree. That would have gotten 4x cubed minus 6x squared. I'm just going to be careful because I'm guessing a seal died. So if we look at that guy, I can distribute him, and you get a negative 2x squared. I rewrite everybody. It just keeps me honest. I don't have to keep on looking back. Did you get negative x next? Okay, so negative 2x squared plus 6x. But subtraction because it's division. Distributing that, adding the opposite. I get negative 5x plus 3.
Oh, okay.
Now what's the struggle?
Yeah, I get it. So it'd be a negative 1. Wait.
What did I do wrong? What's negative x times negative 3? Not 6. It's supposed to be a 3, right? Yeah. Yeah. Now, we could have made that work with like this whole 2/5 thing, but I really didn't want to. Or a 5/2 thing. And I figured it was something wrong in my multiplication. So that should have been a 3x. There we go. Then that distributed to make it opposite, so negative 2x plus 3. There we go. And then all I need is a negative 1, right? Okay. Just for those still peeking, they end up being the same thing. Canceling out remainder is 0. For those of you guys that are just curious, 4, negative 8, 1, 3. If you had done synthetic, 3/2 times 4, just in case you need to see it. The 4 and 2 reduce, you end up getting a 6 actually. Then if you multiply, well, adding down, sorry, negative 2, multiplying by a 3/2, the 2's reduce, and you get a negative 3, which would be a negative 2 again. And then times the 3/2, the 2's reduce, a negative 3, which is also a 0. And you're like, oh, it worked, except you have to divide everything by 2. Because that 2 needs to be divided as well. And so then you would go ahead and take 4x squared minus 2x minus 2 all divided by 2 because of that little 2 out there. Then you get. Joe, see what I mean by sometimes it makes it a little harder? It's not impossible, just harder. More things to remember if it's not the nice people. Yeah. This guy, I love synthetic's perfect, but as soon as it's something different, I have to think about extra pieces and it just gets messy. Yeah. Divide the result of the synthetic by 2. Because if you just divide by, if I get my highlighter out, if you just do 3/2, you're only considering part of it. You need the other part after you're done. Yeah. So some of you might want to play with that a little bit because you really like synthetic. I get it, I do. So I showed it to you, but it's just a warning. Huh? Yeah, like if the long division would be really hard and messy, yeah, it would make it faster. But you have to be okay with fractions and be okay with figuring out what to divide by at the end. I don't know. For some of you, it might not be a good idea. Complex numbers. Let's go. When's homework? We're doing a section in a day? Yeah, we are. It's complex numbers. Tyler. Oh, I gave it to you yesterday. Yesterday was a Monday. Let's go ahead and let me check out your calendar. We could do Friday, but I don't totally mind giving you guys the weekend, except it's homecoming weekend. I'm not really sure if that's going to give you guys tons of extra time. You guys start taking notes and let me peek real fast, okay? You guys start taking notes and let me peek real fast. There is a homework due on Friday. But it would definitely be to your benefit to have it out of the way since there's a test coming next week. Next Thursday. Wednesday's PSAT. It's just a work day for anyone who's here. I think almost all of you will be gone. We'll review Tuesday. PSAT, yeah. You know what? For your own good, even though you won't like it, I'm going to go ahead. Next week. Sorry, I'm talking about next week, and I'm planning ahead because I don't want to make the corrections due in the midst of you studying for your test. So I'm going to go ahead and have the corrections due Friday. I will allow it, though. There is a homework due in class on Friday. I will allow you to turn it in by the end of the day Friday. I'm going to have the folder open. My advice would be everyone turn it in class, even if it's not done, but you can come back after school and work a little bit more. But if there is Powder Puff on Friday, you could come in during lunch and finish up if you need to. Or period 7 if you are an athlete and that's like a study hall time. But test corrections. Homework 7 a.m. like normal, but because homework's due the same day, I'll let you guys have a little bit longer if you need on Friday. But I do need to go out and supervise Powder Puff, so I won't be here super long after school on Friday. Okay, let's figure out why on earth I thought that we could do this section in a day with homework questions and an opener. Whew. It's because you've seen it before. This is just I. Yeah, square root of -1, just I. Square root of -1, just I. So how could you, down here below, if the standard form of a complex number, moving beyond just imaginary has I, complex numbers actually have an A plus BI component. A is the real guy. BI is the imaginary guy. So a complex number puts the real and imaginary together. But if you were just to have A, let me write an example down. BI. Yeah, if you look at math equations, the variables are always italicized, like x's, like f of x. So I just put the I in italics. But let me do an example. To rewrite as a complex number. How could you rewrite something like 7 as a complex number? Making it too hard, but no, that would be -7. No. I mean, that's true, Joe. But I mean as a complex number. Careful, I can't say 1i because it doesn't have any imaginary part, but I could say, couldn't I? Any real number can be written as a complex number just with a 0 imaginary part. Just like you guys are writing down 0 for x squared sometimes, or 0 for x's, and you're like, oh, I know that there could have been one, but there's not. Same thing. There could have been, for a complex number, there could have been an imaginary part, but there's not. So we could actually make any real number written like a complex number. But we can also take any imaginary number and write it as a complex number. How can we write the square root of -49? 7i. But as a complex number,
7 plus 0, 7i plus 0.
careful. 7i is here. What goes here?
0 plus 7i.
There you go. So we could technically take a real number and write it as a complex number, or we could take an imaginary number, just 7i, remember? You could make this into the square root of 49, 7, times the square root of negative 1i. But to make it as a complex number, technically, all nice and pretty, we would put the 0 in front. Only if they're asking you to identify the real and imaginary parts. Does that make sense? So it's kind of like on that weird cubic. Like for synthetic and long division, we write the 0, but we don't otherwise. It's kind of like that. Okay. So the beginning of today was just like, hey, can we remember or at least cover complex numbers are written with real and imaginary parts. Sometimes you'll just have imaginary, sometimes just real, sometimes both. But the rest of class today is pretty much, can we do operations to these complex number guys that you saw last year? I'm not going way in depth in imaginary numbers because you saw it before. Our hope is that adding, subtracting is easy because usually it's the easier of all the operations. Easier than multiplying and dividing. So as you guys are getting this set up, I want you to think, which of the examples is more dangerous? In math? Danger? Subtracting? The rest of you guys help me out. Why did Joe say subtracting is more dangerous? Well, you need to distribute. Hopefully, Matthew said you are distributing. Well, hopefully you are. But what might some people do? Kill a seal. So is it okay, kiddos, for us just to go ahead and stick with the directions from up above? Just combine like terms? What do I mean by that? Well, first of all, no danger here because positive 1 keeps everything the same. But, I mean, danger if mental math is a struggle, right? But combining like terms, what do you get? Yeah, you got it. Combine like terms. Combine the reals, combine the imaginaries, dun 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 dun. But when you go to the subtraction, let me give you a second. Please don't kill anything. Go. It's like when you were little, Mom took you in a shop with lots of breakable stuff. Please don't break anything. Please don't kill anything. You got it. How did I do first? Did what wrong? Did I do it right? Okay. Remember, we add the opposite. Got it. And then combine the like terms. The real, 3 minus 5. 4i plus 3i. Dun 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 dun. So how'd you do? Got it? Okay. What are we going to avoid killing? Seals. Hopefully everything, but right now seals. Does it get any harder? Well, I want to give you a second to go like you would naturally go. You guys have so much math training, even though sometimes you're in denial of it, or how effective it is or was. Do what you think you should. But this time I'm not worried about seals. Do what you gotta do. You got it. Please don't kill those puppies. I see some people being very, very careful, and I love it. Doesn't go as fast, maybe, as some others, but I love the people being super, super careful. Because they know if they try to do a shortcut, they might mess up. Not saying you had to, Just saying I love how many people I just saw doing that. Great job. So question, why is the final answer 12 plus 16i? Maybe some of you know that a plus bi is what I wanted the number to look like. But how on earth did I get there? Jason?
So when you have the 4x squared, where
Why?
because the square root of negative 1 equals I.
Huh?
You multiply the negative 1 to the 4, and then combine like terms with the 16.
And those guys can combine, huh?
Yeah.
So 8i plus 8i is 16i, the outer and the inner combine.
Yeah, I got all of that.
And I squared becomes negative 1 because the square root of negative 1 squared is just negative 1. So the crazy thing is an imaginary number times an imaginary number is real.
Oh, that's how you got it.
So then 16 minus 4 is 12. 16i remains. Here's a snazzy math terminology thing. Complex numbers are closed under multiplication. I'm not going to make you write it down or memorize it or go into theory of what it means. But basically what that means, complex numbers being closed under multiplication, if you multiply a complex number by a complex number, you get a complex number. Seems a little crazy, I know, but you don't have to stress about where it comes from or exactly even what it means. But you should know when you multiply or when you divide complex numbers, there is always a way to end at an a plus bi. Now, just to help you guys out with multiplying, and because I know you saw it last year, let's talk for just a second about how I to higher powers, and that was, I think, one of the end topics for today, simplifying I to the n power, I to some power. Let's talk about how I to any power can always be simplified down to either 1, negative 1, I or negative I. But who or what, which is which? You should never leave an I to a power, and here's why. You should never leave an I to a power, and here's why. I is the square root of negative 1, which we can do nothing with. It's just itself. I is the square root of negative 1, which we can do nothing with. That's the whole reason that this whole notation of imaginary numbers were brought about. It's just itself. But, as you guys just saw Jason do, I squared, since it's I times I, we could say it's square root of negative 1 squared. That's something that we can deal with. Squared and square root reduced to negative 1. I squared is a real number, not just any real number, negative 1. I cubed. I could write this as the square root of negative 1 to the third power, but it's a little bit nicer to build on what we already have and say, oh, it's going to be I times I squared. Break it up. And the reason Joe keeps on saying negative I is because what did we just say I squared is? So if I do I times negative 1, negative I is the result. Now I to the fourth, I could make it I cubed times I, and it would work out, but it's a whole lot easier just to make it I squared times I squared, because that's just negative 1 squared, and negative 1 squared is positive 1. Out of those four, I, negative 1, negative I, and 1, which one is the easiest as far as how it simplifies or what it simplifies down to? Yeah. So guess what I'm going to do from here on out? Always think in multiples of 4. Because I can think 5. Hey guys, divide 5 by 4. What's your remainder? 1. So I can say I to the 4th times I to the 1. I to the 6th, what's your remainder when I divide by 4? The 7th would be a remainder of 3. 8 would be a remainder of, well, nothing, because 4 goes in evenly, right? And how does this help? What do all these little I to the fourths become? So what am I left with? Times I is just I. 1 times I squared, which is negative 1, is just negative 1. 1 times I cubed, which is negative I, just negative I. And 1 times, wait, I to the fourth is 1. Oh, that's right. What's going to happen every cycle of 4? It's going to repeat. So then take this down at the bottom, I to the 35th. Ugh. But wait, how many 4s go into 35? Can't I say it's I to the 32nd times I cubed, which is I to the 4th, 8 times? Why would I rewrite it like that?
We got the newspaper for y'all.
Thank you. Extra, read all about it, huh? All right, thanks, guys. Kiddos, I'm going to put the stool right by the door. Pick up one on your way out the door. What's going to happen to all these I to the fourths? And what's 1 to any power? Oh, so all that's just 1? Yeah, and what's left? I cubed, which simplifies down to be negative I. Ready, set? Your guys' turn. I to the 129th. Don't shout out any answers. Take a second. Can you figure out where that would fall? And as soon as you think you have it, turn to people in your group and be like, you guys ready? Second. Why are you saying answers? Oh, good. I was going to say that's not the right one. Then more than once. Every I to the fourth just becomes a 1. What you care about is the remainder. Okay, pause, collaborate. Don't just give an answer. Don't just give an answer. Ask them how they did it. What did you do to 129? How did you break it down? Still see a few people breaking down. Okay, group 2 and 3 and 6, talk. You've not talked yet. Turn. Turn, Wesley. Make him face you. Fredo, make him face you. You don't have to have an answer. Just talk about what you've tried so far. Doing a division, someone in your group can make faster. It's not a bad thing. I'm not answering it. Talk it out. What's missing? How many I to the fourth did you guys find? How many are left over?
1.
What happens to that whole thing? It just becomes a 1. And what's 1 times I? Dun, 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 dun. We okay? So I to any power, should it stay to a power? Or should it always simplify down? Okay, I to any power should always simplify down. And I don't think you guys are even going to see I to crazy powers, but it was a thing you saw last year. I wanted to review it quick because we're going to use it this year anytime we see an I squared. We're going to make it a negative 1. I wanted you guys to know why. But we can't just stop with multiplying. We're supposed to do all the operations of complex numbers, adding, subtracting, multiplying. Last one. Here we go, dividing. I told you guys that when we multiply or divide a complex number by a complex number, we should always get a complex number. But here's the crazy thing. This doesn't look like an a plus bi. So how on earth do I make this division look like an a plus bi? My little hints are over here to the side. What to do if you are just dividing by an imaginary part, and what to do if you're dividing by an entire complex number. So if you're dividing by just an imaginary part, do this. Multiply by I as you multiply by 1 creatively. If you're dividing by a whole complex number, a real and imaginary part, multiply by the conjugate. Now, when we multiply by 1 creatively, don't we have to multiply the top and bottom? Top and bottom? So if I'm saying multiply by I, what I mean is by 1 creatively, an I on top and an I on bottom. How on earth does this help? Who's this guy? I squared, yeah, it's just -1. So if I divide 5i by I squared, which is just -1, don't I just get -5i? Which could be a 0 minus 5i. There's my complex number. And that's so much easier to deal with than this weird 5 divided by I thing. That's much more normal. Now this wouldn't work if we just did I divided by I. You could try it. If we just did I over I, an I over here, everything's messed up. But if we multiply by the conjugate of the division, of the divisor, of the denominator, keeping everything legal, this is following my note as to what to do. Some of you guys just worked really hard on not killing anything when you were foiling. So hopefully you'll be able to follow as to how I get 6 minus 7i plus 12i minus 14i squared. And 1 minus 2i plus 2i minus 4i squared. Some of you right away are like, this is not helpful, but look. The I terms, the difference of squares, the I terms go away. The I squared becomes a -1. So I actually end up with 6 plus 5i. Hey, there's another I squared, which becomes a -1. Plus 14 all over 1 plus 4. 6 plus 14 is 20, right? 20 plus 5i divided by 5. Now, some of you were like, it's still division. We can break this up. And Joe, even though I appreciate you going all the way, I actually think it's more important for us to realize that when we divide by a constant, we have to divide all the pieces by that constant. Which in this case do simplify, but just a heads up, sometimes they're nasty fractions and it's okay. You still, no matter what, will get to a complex number at the end if you properly multiply by the conjugate. Adding, subtracting, multiplying, dividing, complex numbers. Why? Section 2.5 says polynomials sometimes have real zeros, sometimes have complex zeros, sometimes have both. So this is just a little timeout in between complex numbers. What are they? Before we go back to polynomials. Bye, guys. Homework due tomorrow because look, we're done. Get your paper on the way out. Get your paper on the way out. Thanks, Joe. Support the journalism staff. They work hard.